Hello, students. I hope you are all doing well. Let's start today's lecture, which is about the integral calculus. Okay, integral calculus. Let's start. Oh, before I want to tell you one thing. That is, if you are a new person who is listening to watching my videos or lectures, please do subscribe to my channel. Your one subscription will motivate me to do further videos of beautiful concepts of mathematics. Okay, let's start. I hope you subscribe to my channel. Let's start. Okay, in this lecture, we will start with the reduction formula. Reduction formula. Okay, reduction formula. In this, let us reduce or reduction formula for for integration sine power n x dx. Sine power n x dx. Okay, where where n is positive integer. N is positive integer. Okay, n is positive integer. Let us reduce this. Let us simplify this. Okay, let let I will take in. In is equals to integration sine power nx dx. Okay, sine power nx dx. Now we can write this integration sine power nx dx as in is equals to integration sine power n minus 1 x into sine power 1 x dx. Right, you can write now. Okay, then in is equals to, tell me what is the next step, what we can do. I will give you the int. Okay, so I will take this as u and this as v. I will take this as u and this as v. What we can do? Yes, what is that is, we can apply integration by parts formula. Integration by parts formula, right? Okay, okay, let us apply the integration formula for this equation. That is, in is equals to, what is the integration by parts formula? That is, we can write it here. That is integration uv dx is equals to what? Right? U integration v dx minus integration of differentiation of u into integration v dx whole dx. This is a formula for the integration by parts. Okay, we have to apply the particular equation in that formula. Okay, let us apply. That is, in is equals to what? Integration u integration v dx. We have to keep u, that is sine power n minus 1 as it is, and we have to integrate v, that is sine x, sine power 1 x. Okay, we have to, when we integrate sine power x is sine power 1 x, what we will get? We get minus cos x, right? Minus cos x, then minus integration. We have to differentiate u. What is u? Sine power n minus 1 x, right? This is u. So when we differentiate sine power n minus 1 x, what we will get? That is, the formula is x power n is equals to n x power n minus 1. Differentiation, right? Differentiation. So here we get n minus 1 into sine n minus 1 minus 1 x, and the chain rule sin x is cos x. Differentiation of sin x is cos x, right? Then into we have to integrate v, that is sin x dx, right? Sin x. When we integrate sin x, what we will get? Integration of sin x is minus cos x, right? So this ends the application of the for integration by parts formula. Okay. Okay. Now let us simplify this. In is equals to, here there is a minus, right? So here there is a minus. We can take it outside. That is minus sine in power minus 1x into cos x minus, here also minus, there minus is there, right? So this minus and minus will become plus. So plus integration. Okay, let us take this n minus 1 outside. Okay, let us take this n minus 1 outside, and integration sine n minus 1. So okay, will be minus 1 here, minus 1 and minus 1 is minus 2, right? So we can write minus 2 here. Okay, sine n minus 2 x into cos x into cos x is cos square x. Okay, cos square x dx. Here also we have to write dx. Okay, did you understand up to here? Okay, let's move on. And in is equals to minus sine power n minus 1 x cos x, plus, here you can write n minus 1 integration sine power n minus 2 x. Here this, what is cos square x formula? Cos square x we can write it as minus 1 minus sine square x, right? 1 minus sine square x. Did you understand? Okay. Next, in is equals to minus sine power n minus 1 x cos x, plus, here we can multiply this whole term to this, right? Let us multiply. That is n minus 1 integration, this whole term multiply by 1. Okay, when we multiply to 1, it will become same. N minus 1 integration sine power n minus 2 x, here plus, here we have plus, here we have minus. So minus, plus into minus is minus. So when we multiply this term to sine square x, it will become n minus 1 integration sine n minus 2 into sine square x dx. Sine square x dx. Okay. Okay. Shall I will rub this. Okay. Then in is equals to minus sine power n minus 1 x into cos x plus n minus 1. I will write this as it is, n minus 1 integration sine power n minus 2 x minus n minus 1. Now, what is when we multiply the bases, when the bases are same, the power should be added, right? So, when we add this, here there is a plus sign, here there is minus sign. Plus into minus is minus. So, these two will cancel. The remaining part is we get integration sine power n x dx. Did you understand? Okay? Okay. Let's move on. In is equals to minus sine power n minus 1 x cos x plus n minus 1. Here, what is in is equals to, here we have in is equals to integration sine power nx dx, right? So here we can write in minus 2 is equals to integration sine power n minus 2 x dx. Shall I write? We can write no. Okay. Okay. Let us write this term as in minus 2. Did you understand? Okay. Then into, here we have minus, so minus n minus 1 as it is. The same here, in is equals to integration sine power nx dx. Here also we have the same integration sine power nx dx, right? So we can write here as in. Okay. Okay. Then in is equals to minus sine n minus 1 x cos x plus n minus 1 in minus 2 minus, here we can multiply this in to n minus 1, right? So let us multiply that. Minus in, here minus into minus will become plus in. 1 into in is in. Okay, let us shift these term to the LHS. Okay, because the in part, right? So we will take away from these terms. Okay, okay. Then in, when we shift these two terms to the LHS, we get plus n in minus in is equals to, here there is minus, when we shift to the LHS part it will become plus. Okay, okay, is equals to minus sine power n minus 1 x cos x plus n minus 1 in minus 2. Okay, then here plus in minus in get cancels, and the remaining part is n into in, which is equals to minus sine n minus 1 x cos x plus n minus 1 in minus 2. Okay, then here we have to get only in. Okay, we have to reduce this integration sine power nx dx to here in. We have to reduce this in to in minus 2. Okay, so in is equals to, here also we have in, so we have to get in here. So in is equals to minus sine power n minus 1 x cos x plus n minus 1 in minus 2. Okay, then whole divided by this cell will move to the denominator, that is n. Okay, then in is equals to minus, we can split this, that is minus sine power n minus 1 x into cos x divided by n plus n minus 1 into in minus 2 divided by n. Okay, did you understand? Okay, so this is what the reduction formula for this is what the reduction formula for the integration integration of sine power n x dx. Okay, integration of sine power n x dx. Okay, so this is what the reduction formula. Okay, then there is a reduction in the power from there is a reduction in the power from n to n minus 2. Okay, n to n minus 2, that is n to n minus 2. Okay, then there is a note here. Take on the note, that is note the last integral the last integral the last integral is I naught if if n is even and the last integral is I1 if n is odd. Okay, this ends this lecture. Let's meet you in the next lecture with the problems of based on the reduction formula for integration sine power nx dx. Until, take care, thank you, bye bye.